Are we ready to start, everybody? Excellent. Okay, multivariate. I don't need to go through the whole syllabus, right? We can read it on our own. The multivariate, 9 to 11:55. We'll meet every Monday morning. You will get a break, of course. If you need to call me, you got my phone number. No one calls me anymore, but please feel free to. And here, T Glaser at Alliant, or more urgent, my Glaser console, if you need to email me. That's actually a preferable email. Either is fine. If you want to meet with me, I can meet either on campus here right after class. I'm going to hang around here until about 1 o'clock. Then I have a class at San Diego State at 2. So I do have to get on the road. Or if that hour doesn't work for you and you want to have one-on-one time with me, I will be happy to schedule time throughout the week. I'll make time for you if you want that. I loved what Dr. Lisa Harlow, she's well known in quantitative methods and psychology, presents at APA, said. She said early on she saw that even as a kid, she saw that we inhabited a multivariate world. Again, I doubt as a 9-year-old, some kid said, wow, we inhabit a multivariate world. I doubt she said that, but I know what she was getting at. She lived on a farm, and she saw that there were a multiplicity of influences. You know, she was raised on a farm in Kansas. And she said, I saw a lot of things work together, whether it be, you know, tending to the crops, you know, the animals, etc. And actually, she's one of the head editorial reviews on multivariate behavioral research. And so she's a multivariate scholar. A glance at the Applied Psychological Journals, Journal of Applied Psych. In business, you'll see things such as Journal of Marketing Research, for instance, personnel psychology. Almost every of those journals use multivariate techniques. Organizational research methods. Now, you actually, whether you knew it or not, you actually were exposed to some multivariate techniques in my other classes. When you started doing, remember multiple regression, everybody? Yeah. That's a multivariate technique. It really is. You have multiple IVs. Remember doing even ANCOVAs and repeated measures? Those also start to become multivariate techniques. So the fact is, with the infusion of structured equation modeling and multi-level modeling, how many people have heard of structured equation modeling? You've heard me talk about it quite a bit. And multi-level modeling, when you have nested structures. All of those, you're going to see that we've gone way beyond 2x2 ANOVAs. Now, 2x2, sometimes is all you need. Sometimes a t-test is all you need. Sometimes a correlation is all you need, and that'll be fine. But sometimes the research questions you ask are very complex. You have multiple influences, multiple outcomes, and multivariate statistics is able to accommodate that. Plus, you even see, I mean, I even look at businesses now. You ever heard of departments called analytics? Qualcomm, all the big companies have analytics. They're all doing multivariate techniques, even though they're doing a lot of data mining. Things like neural networks, supervised learning, regression trees. I mean, they do pretty sophisticated stuff. But the fact is, we know that we live in a world that there's a multiplicity of influences. Think about after Connecticut. How many people are, again, trying to figure out what predicts violence? How many people try to come up with predictive models? That's been going on for years. What do we say when we find out some next-door neighbor went on a rampage? What's the thing you hear a lot from neighbors? What do you see in the newspapers all the time?
Never would have expected.
What's that? Absolutely.
Their household that they grew up in when they were a child.
Maybe household. Did it matter that in Connecticut she owned 3 guns, the mother? Maybe, maybe not. Right? All types of things. So we're always trying to ask these questions. So what you're going to find in the course description, we're going to talk latent structure models with attention to the relation between latent constructs. Where we're really going to get into latent constructs is when we get to structured equation modeling. What does latent mean? It means that essentially this complex thing called motivation. Do you guys all know what motivation is? Okay, good. Give me a definition. You guys use the word all the time. I'm motivated. He's not motivated. Go ahead. Define it for me. Make it real, that I can touch it, feel it, see it, think it, breathe it.
It's a consistent individual desire to perform certain behaviors.
A desire to perform behaviors. Can you tell me what desire means, please?
An inclination to, or...
You got a construct within a construct. I mean, desire could be its own construct. Yeah. But it's complex, isn't it? Yet we use that terminology a lot. Even in performance appraisals, they're not, Chad's not motivated. Well, what the heck does that mean? But a lot of times we may have multiple measures of motivation. We may ask questions very similar to what you said. I don't feel like working on the tasks, etc., etc. This is a latent variable. It's unknown. It's a construct. And in psychology, we work with constructs. Motivation, personality, emotion, job satisfaction, organization, commitment, desire. Those are all just constructs, theoretical entities we've made up. But one of the last things you're going to do in this class is be able to test this via structure equation modeling. And we're going to deal with the notion of a latent variable a lot in this class. You're going to learn. So the first couple weeks is going to be kind of review for you, the first few, except for one chapter. Today's going to be total review about assumptions, thinking again about significance testing, power, missing data. We're going to go over some general issues that never hurts to go over. Number 2 chapter will be new to you. It'll be matrix algebra. Number 3 will be not new to you. It'll be multiple regression. I don't know how much you had with multiple regression. You haven't? Okay. They've had a lot. They had a whole semester of it. So that's why we'll work together on this. But yeah, I know there's a little disconnect there. But multiple regression, but it'll be good for you to think about. Because I'm sure, Chad, you've been thinking all summer again about the various assumptions, influence, heteroscedasticity, maybe thinking about Mahon-Boyd distance, leverage, DFIs.
Yeah, I did some diagramming.
Diagramming?
Yeah.
All right. That really doesn't make sense, but I'll try to Chad.
Neither did what you said.
Yeah. I know, good. So that being said, I figure even multiple regression will be good to review. And we got 2 students that are currently taking it, so you're getting a 2 for, yeah, yes, this is going to be completely nice for you, right, even for your test. You're going to learn about discriminant analysis. You're going to learn about canonical correlation. You're going to learn about MANOVA, when you have multiple outcomes. You're going to learn about a little bit, which you will not do multi-level modeling. You're going to learn about path analysis. You're going to learn about structure equation modeling. And then briefly, though it's not on the syllabus, I want to introduce you to some other techniques that will be like 10 minutes each. I want to introduce you to survival analysis, which probably isn't even taught at this school. I want you to know what survival analysis is, and a couple other multivariate techniques that really aren't in these books, but may be in this one.
Survival analysis
Is in this one, right. So I just want you to know about survival analysis. So you're going to have a rudimentary comprehension of matrix algebra. This class used to be mathematical, which means you actually were one of the few people in San Diego that did a MANOVA by hand. One of the few people that took determinants and logarithmics of determinants. And I stopped that last year. I mean, I think it's still important to do the math. I'm going to show you the math. I'm going to show you the math. But you will not have to do it for your homeworks and your take-homes. So this class used to be a lot of matrix algebra. But I still want to show it to you because, as you know, I don't want it just to be a black box to you. Because it's easy to run this on the computer. It takes 2 seconds. And I've had some students say, why do we ever have to do anything ever again by hand when I could just plug a button? Because it's my opinion, and I'll die with this to my grave, is that knowing the math behind it makes you have a deeper understanding of it. I know teaching even at undergraduate, when I know the math something, I can explain it conceptually that much easier. So I'm going to show you the math. I'm going to show you the matrix algebra. You will not have to perform it. The only matrix algebra you're going to have to do by hand on the test will be multiplying 2 matrices. That's it. But I'm going to show it to you because I really want you to get it. You're going to interpret SPSS up, and I'm going to be giving you homeworks. I changed them. As opposed to having all these written homeworks I've had in the past, at the end of each chapter, I'm going to have a database that I've put on Moodle that we're going to work with throughout the semester. And I'm just going to spontaneously pick which variables I want you to analyze, and you're going to do a write-up. I'm going to let you work in twosies for the homeworks and the take-homes. I'm going to let you work in 2s, no more than 2. 2 is it. One of my TAs brought up an interesting observation, which I agree with him. He said, Dale, we've started having more than 3, and there's been what's called the social loafing effect. Now, you have that third person that some people have been dragging on, and I agree. So you guys do get to work on a homework, but maximum of 2. You're going to get a foundation in structure equation modeling, a foundation a little bit. You're going to get about 2 or 3 weeks of lecture. You're going to run it. So you'll know enough to be dangerous. You'll know enough to be able to run it in the software that Alliant has a license for called Amos. But you won't be an expert in it. We need a whole class devoted to it. In fact, if I played Curriculum King, I'd have 6021 as is, ANOVA, 6022 regression, multivariate, and then a whole class devoted to structure equation modeling and multi-level modeling, and I would add finite mixture modeling, which I am going to talk briefly about at the end of the semester. Just so, because you're going to start seeing more and more people using all of these tools. So, that being said, everybody, participation, as you know, that and attendance I don't grade on, but do try to be here. Data set, I have a data set that's cleaned up. You don't have to do anything with the data set. It's already cleaned. And it'll be good. You'll be using it for homework, and I'll be announcing them. Each homework will be about 10 points. And basically, the homework is just an opportunity for you to practice, to start to write it up to the best of your ability in APA style. And you do get a work in twosies. Short answer, multiple choice interpretation. There's only one in-class exam. There's one in-class. It'll be 150 points. And then 2 take-home exams, where you'll be able to practice and write up the results.
Is the in-class a midterm or a final?
It'll be more of a midterm. It's later. It's after Chapter 7. It includes up to discriminant analysis. Now, everybody, this is where I may have to get a little flexible. You will be doing structured equation modeling, a project, a research paper. You're going to do both a confirmatory factor analysis and a structural equation model. You're going to get some nice practice in Amos. I've already put up lots of documents that'll help you kind of, thank you very much.
Sure.
Thank you, Justin. That'll give you kind of a start on Amos. There's a couple things that Sharon Foster has given me. People have even found tutorials on YouTube with Amos. What's nice about Amos is it's all graphic. It's graphic. There's no computer, there's no syntax you have to learn. So, what you're going to do is you're going to have a model. You will come up with your own model of the variables I've given you, very simple model, and you're going to get about 4 or 6 articles for lit review, and you're going to run the model. Now, what I'm hoping to have that may not happen is this part, in-class presentation. There's going to be a PowerPoint and in-class, so you would present. The problem is we have been, unfortunately, short-shrifted one class. I don't know if you looked at the syllabus,
Yeah.
but unfortunately,
President's Day?
well, what's happened is we got President's Day, midterm, break, right, no classes, and we started late. We started today. And the class doesn't, I was hoping, and like what USD does when that happens, it'll end the semester on a Tuesday. That's what USD does. Alliant ended it on the prior Friday. So we lost a week. We lost that I really, really, really needed. So, I'm hoping to have this. There's a chance that this may be a lecture and you won't have a presentation, but I'm still going to want you to submit a PowerPoint. Okay, I'm still going to want you. So this we're going to have to play it by ear, everybody. We're going to have to play that by ear. Because there's a chance I'm going to give you a little wiggle room on that. I'd love you to do a presentation, because I think the more presentations you do, I think it's a valuable skill to have. I think it's a valuable skill to be able to talk about results in your own science in front of the class. So we'll play that by ear, everybody, because we did lose 1 week, unfortunately. The book, Stevens, is a very, very, very user-friendly, what I call a non-technical book on multivariate. It's a great book. I've been using it for years. I love Tabachnik and Fidel, their other book. There's about 8 other multivariate books that I like. Johnson and Wicker is a little too technical. So, but this one will do the trick. It's a slight book. I mean, it could easily be 1,000 pages, which the new Tabachnik and Fidel is. So this book is great. It'll be good enough, and I will go and supplement when I feel. These are completely non-technical. People love these books because they're completely non-technical. They're APA books, and they're just, what's that?
They're awesome.
Yeah, people love these books. Again, they're simple, but not too simple. They get into it. But these will be wonderful books to supplement the chapters. So these are 2 books that will be wonderful, wonderful non-technical books for multivariate stats. So that, everybody, that concludes just the intro. Any questions at all? Any questions? What I will do is I will use the book as my basic lecture guideline. Last year, up to this year, you should see I have a whole box of overheads for each chapter. And this was painful for me a year ago. The overheads are that thick, because I've been teaching this since the mid-90s. And I realized last year, in fact, there's not even an overhead here. So a year ago, I realized that As one student so delicately said at USD when I pulled on overhead, she goes, "Oh, old school." And you know, she was 19, and I said, "Thank you, I like overheads." And I had all these overheads. So what happens, I started a notes. I started notes, which you wouldn't know, but in my other classes, I have these works in progress. They're really not lecture notes, but they are. People do use them for study. I started this last year with multivariate. So these notes are not comprehensive. They supplement the book, but it's good enough. So now what I've done is I no longer have overheads, which I really miss. I had great overheads.
Could we recreate those as PowerPoint slides, though?
You can,
Okay.
sure. I'd be happy to give it to you.
That's a possibility.
That's so nice of you to volunteer. Just come to my office and
if we can get some credit or something for it, absolutely some
no, but you'll do
internship
it
stuff.
because you'll feel good.
Well, I
about
always
yourself.
feel good.
Actually, you know what I did do, Chad? I went through the summer. I knew that I couldn't use overheads anymore, and once I got the tear out of my eye, I actually had the overheads. And when I started creating the notes, I went through each of the overheads, the ones I found. What does univariate mean, everybody?
One variable.
Yeah, one variable, maybe one IV, one DV. So some of this will be review. Quite a bit of this will be review for you. When you engage in significance testing, what we call null hypothesis significance testing, as you recall, you make a decision. What's that decision you made, everybody? You get an interesting research question. Maybe you want to look at maybe group 1 gets some type of training. Group 2 gets control. They don't get anything. And what is significance testing useful? To be able to test what? For the simple two-group design. We want to see if what? Let's say the DV is job satisfaction.
There's a difference between the two groups.
Between the two groups. We want to see if there's a, and how do you know if there's a difference between two groups, Jocelyn?
I don't know anymore. I read those articles you put up and I'm completely confused.
Because that'll be your first homework, is actually making sense of those. So, with null hypothesis significance testing, so this might be good to have a little re-review here, is you are testing to see, obviously, if there's between group differences, correct? And the notion of significance testing is the difference is large enough that it couldn't have happened by what? Chance or error, given a what? A true or false null hypothesis. What are we assuming, everybody? When you're engaging in the enterprise of significance testing, and you've got two groups, and you have a null hypothesis, we'll say the mean of one group equals the mean of the second, and the alternative, the mean of the first, does not equal the mean of the second. We're assuming the null is true or false in nature.
True.
True. We're assuming it almost looks like this. The two groups are overlapping. But the onus is on us to furnish evidence against this. And you get partially that by what? What did you read in the statistical output that helped you determine or demonstrate significance? The p-value. Exactly. Exactly. So say in the univariate case you have two groups and your DV is performance. One group gets training, one group does not get training. Right? So basic between group. And as you know, and as the book gets into on the page 2 to 4, and again, some of this is review, but it never hurts. When you decide to make a difference, you can make an error. You can make an error. Do you guys remember the errors, type 1 and type 2? Someone explain to me what type 1 is again.
Type 1 is when you reject the null hypothesis when you shouldn't reject it.
Right, the probability of wrongly rejecting the null when the null is what, everybody? Yes, when it's true, exactly. Probability of wrongly rejecting the null when the null is true. Saying there's a difference when there isn't. Or we also call that, in medicine, guess what they call that a lot, everybody? You've heard me say this in my other classes. False positive, right? You hear that a lot in medicine, right? To make a false positive diagnosis. So, we have the null and the alternative, and then you're going to make a decision, which you've been doing from all your stats classes and your own research. So type 1 error, and a lot of times, we also call this alpha. Right, everybody? What is alpha? Please remind me again what alpha is. What is alpha? Your level of
Significance.
yeah, significance. Who sets that? You or the computer?
You do.
You do. And what's the typical one we've tended to use by convention?
0.05.
Now, do you have to use 0.05?
No.
And it's interesting when you look at the initial papers by Sir Fisher in the early 1900s. He had one paper, and someone showed it to me at a conference. It was like a thermometer. And it did have 0.05 in the thermometer, but all he had words like more evidence against the null, increasingly less evidence. So he actually had descriptors, but he never said you have to use 0.05. But it has become convention. So the null hypothesis, you have a null and alternative for the simple two-group design. Right? It's as simple as it can get. We've already done that. Just to remind me, for two groups, what type of statistical test could you use with a continuous level outcome?
T-test.
T-test. Could you also do a one-way ANOVA, Jocelyn? Yeah, absolutely. Will the ANOVA be equivalent to the t-test? Yes. And do you recall the relationship of t and f? T squared equals, remember, t is the square of t equals f. Very good. It's all coming back. So, that being said, everybody, type 1 is one type of boo-boo. So here, when you look at what sometimes these are called the truth tables or decision tables, so type 1 is a false positive. If you fail to reject the null and the null is true, what are you saying? If you fail to reject the null and the null is true, you're saying there's no difference, and indeed there's no difference.
Wait.
See, I said fail to reject the null, and the null is true.
So you're right. Oh, okay, so that's your correct.
Yes, true negative. It's a true negative. Right, everybody? So the problem, and I know that language, the double negatives, drives you crazy. You don't go on a date and say, no, thank you, I will not have that spaghetti. Unless you want to talk in double negatives the night, right? When someone says, I failed to reject your offer to go out this Friday night, are they going out with you? It's going to be an incredibly long night given this type of communication. But, right, I mean, but why do we say that? Some of it, and I'm not going to get into philosophy of science, but Karl Popper, very famous philosopher of science, said the most you can do is falsify. The most you can do is fail to disconfirm. We can never unequivocally prove something. What we can do is fail to disconfirm. So we want to furnish evidence against this. And that's why it drives business people crazy and lawyers. Right? It either is or it isn't. And well, you know, it's a degree of probability. So here we got 1 minus alpha. Oops. Type 2 error. Probability of what's that? Okay, so probability of failing to reject the null when the null is false. Right? So the opposite. So probability of failing to reject the null when, oops, the null is false. In English?
You say that
there's a difference.
There, but
and there is. There is, absolutely. Right? That's what we call a false negative. Right? You failed to reject and the null is false. In other words, you're saying there's no difference, and guess what? So again, significance testing assumes the null is true. Type 1 is our alpha level, but oops, and as Zach said, we have a false negative. Right? We have a false negative. Which is a shame. Think if this training intervention could really help boost productivity, or some type of medication or therapy can really help with outcomes, and you weren't sensitive to it. I know this is rehashed for you guys, but is it helpful going through this and rehashing this? So, type 1 corresponds to our alpha. And as Chad said, the typical level we've used is 0.05. But do we have to use 0.05?
No.
Right. Could I just as well use 0.01 or 0.01?
You would probably want to if you were testing for medication effectiveness.
Okay, we're going to talk about that.
Depends on what level of error you're comfortable with.
Level of error, we're going to, exactly, precisely, we're going to talk about that. So, type 1 corresponds to our alpha. We've set 0.05, but why? So we have 0.05, and if our p-value is less than or equal to 0.05, we reject the null, right? We reject the null. Our 0.05 is basically our allowable type 1 error rate. It's the error rate that you have set. And we're essentially saying 5 times out of 100, if I ran this test 100 times, if I had the luxury of replication, 5 times I'm going to say, I'm okay saying there's what? The difference when there isn't. So you have to decide if that seems like a lot. You may decide, wow, I don't want 5 people out of 100 to have horrible side effects from this medication. I may want to go to what? Yes, 0.01. Exactly. Or maybe some situations it may be too liberal, or even, can you see situations when that may be too liberal, or even conservative? Can you think of a situation when alpha of 0.01 might be okay? Yeah, training's probably not, it's not going to damage it, and there's not going to be a horrible side effect. Oh, I received the training, I developed, some oncological, right? It's probably not going to happen. Have fun getting published with an alpha of 0.08. That's the problem, it won't happen. If you get a P of 0.08, have fun getting published. You might be able to, but it'll be hard. Because they'll say any difference is just due to what? Chance or error or sampling error, absolutely. Now, one advantage of multivariate stats is this potential control type 1 error. We're going to come back to the rest of the quadrants, everybody. We're going to come back to power in a little while. One advantage is that you can control type 1 error. Remember, the complement of type 1 error is what, everybody? 1 minus alpha, right? Where you fail to reject the null when the null is true. But why do we not say accept the null? Fail to reject means the same. It seems synonymous with accept, doesn't it? But when you accept, you're essentially saying what? There's no difference. And there may be. And you may not be sensitive to it. What if you don't have significance for a large difference, but you have 12 per group? Is it possible to have a nice effect between these two groups? Is it possible that, you know what, wow, training really created a 5% increase in performance? Which maybe you say, wow, once you start putting that in dollars and cents, that's a substantive increase. Or my P equals 0.09. Why might I have a nice effect and yet a failed to reject decision? Yeah. What if you had 15 per group, NJ, where J equals group? Is there a chance? In fact, it's not always easy to get people, is it? I've seen dissertation students say, wow, I thought I was going to get 150 people, lickety split. They've got 20, 30 people after 2 months of recruitment. It's not easy to always get people. So, as you know, type 2, again, is the probability of failing to reject the null when the null is false. Saying there's no difference when there is. So what if you had a nice 8-point difference? An 8-point difference. Look at the raw mean difference. You may say, wow, coaching versus no coaching on performance, that's a nice difference. But guess what? You have 15 people per group. What do you do then? What do you do then? You got 15 people per group. You actually show what you consider to be clinically, organizationally, practically speaking, a nice between group difference. But oops, you don't get the holy grail of P less than 0.05. What do you do? What would you do? And let's say future funding, promotion, fame, and glory is based on the findings. What do you do?
Try to get more people.
Try to get more people. What if they say your budget's constrained, you can't?
Report your effect size.
Report the effect size, and will your boss know what the effect size means? What if they kind of know significance is really important? They know significance is important. They took a stats class 20 years ago. Effect size is something kind of new to them.
So it was approaching significance.
It was what? It was a what?
Say it was approaching significance.
Oh, okay, yeah, and you will see some articles that'll say marginally significant. I mean, people that know a lot more than me, I've seen them use the term marginally significant.
I saw that last month, and I thought about you, and I was like, ooh.
You'll see that in Journal of Applied Psychology. Those are people who are a lot brighter than I'll ever be. And I strongly disagree with that. I'm totally on the side of Bruce Thompson, who's been railing against that for years. As he said in APA, he said, how do you know it's not avoiding significance? It was almost like you're reifying this thing. You know, it either is or it isn't. So, what I probably would do is say it's a nice 8-point difference. If there's no budget, then you've got something interesting. But the fact is, you said get a bigger sample size. Does a larger sample size guarantee this continued 8-point difference? Right, you're right. See, sometimes people think if I get a larger sample size, it'll guarantee that the effect size will stay the same. You may have gotten luck of the draw here. You may have gotten luck of the draw. So, then the last quadrant is good old what, everybody? What's the biggie? Power. 1 minus beta. Right, 1 minus beta. Let me see right here if I can, oh look, it opened it up 4 times. I'm going to kind of take Chad's word for now and just open it up in here. Close your eyes, here's my password. So I just put these last week for you guys. I have all types of files for you. You can see I don't organize this real well. You'll see it's under notes, but there it is. That would be called plagiarism. But it's a really nice detailed presentation on power analysis. And these questions come up a lot. We're going to discuss power analysis in a little while. But what is, again, thinking of power? Probability of correctly rejecting the null when the null is what? False. When the null is false. In English, saying there's a difference, and there is. What we call a true positive. And that's why you're doing the study. When all is said and done, everybody, you hope to find a difference between groups. With a MANOVA, you hope to find a difference between groups on multiple outcomes. With discriminant analysis, you hope that these predictors do a good job of separating the groups when the group is the outcome. With multiple regression, you hope the multiple variables predict the outcome. So power is a big part of doing this type of analysis. So, what affects power, everybody? And power is beta. As you know, power is right there, 1 minus beta. So now this is the quadrants that you've gone over many times, and you know, from undergraduate on, I go over it every semester, every class, and people are still appreciative, and sometimes people still get confused. So that's why this is something you can never, never, never go over enough. So I know we've had this discussion, and maybe you've modified your thinking. What's worse, type 1 or type 2? And try to avoid saying it depends.
It's contextual.
Oh, God.
That's synonymous with that
That's
statement.
contextual. That's so postmodern of you. So, but you are right, of course. So type 1, as you know, can have some deleterious effects, right? And our legal system is based on what? Minimizing or maximizing type 1 error. Are you innocent for guilty or guilty for innocent? In America, innocent for guilty or guilty for innocent? Innocent. Innocent for guilty. Which means we've decided what's worse, type 1 or type 2. Type 1 error would be saying someone's guilty when, right? Instead of saying they're guilty when they're what? Innocent. And type 2 would be saying they're innocent when they're guilty. So what have we decided is more problematic in our judicial system? Are there some countries that think type 2 is worse? Absolutely, absolutely. You read about even in the Taliban and so forth, the way they still sever hands, stone, you know, if you have adultery. Sometimes they may make a boo-boo, but they figure, you know what? They want to make sure to delimit type 2 error. Type 1 in America, we decided type 1 is worse. So what gets the front page of the headline? Someone who committed a burglary or robbery or rape and was not convicted and or acquitted and or caught, or someone that spent 20 years behind bars and was exonerated via DNA evidence. What gets the front page of the paper? The type 1 or the type 2? Was that the type 1 or type 2 example? You're absolutely.
Type 2.
Type 1.
Type 1.
No, this
gets
person
the
was
front page.
told they were guilty, they spent 20 years in jail, and they were exonerated by DNA evidence. Absolutely, absolutely. But your first job, they give you $60,000 to do a training program. 60,000. Oh man, you get P of 0.072. Wow. Fame and glory and continued employment was based on significance, given your alpha of 0.05. Wouldn't it have been nice if you set 0.10? You guys okay with changing your alpha after you look at the data? Yeah, but Josh, your boss won't know the difference. We will, but your boss really won't. 0.05, 0.10, they say, oh, you know, my alpha was 0.10, and we have significance, and it looks like our training really did boost performance. No, so your sense of ethics will prevent you from that, as opposed to the unemployment line?
Yeah.
We'll see how far
I'll revisit that.
What?
I'll revisit you.
You'll revisit that, right? So that being said, what do you do in that situation? You got 0.072, you got a nice program, you spent $60,000. You did not spend a trivial amount of time on it.
Well, does the entire decision, this goes back to the article again, does it hinge on significance or not? There's so many other...
Absolutely. I mean, with all the effort, time, resources, and money to go to study, it's incumbent, you ask Jane how many participants you need prior to commencing data collection. So it'd be nice for you to have had a big enough sample size, given your anticipated effect size. So what I would do is you just report the effect size, the P of 0.072, and then kind of let talk with the consumer of the data to see, is it still a substantive effect size? So, when is it okay to have a higher type 1 error rate? Maybe it doesn't have grave implications. What if you started a customer satisfaction program at Nordstrom's? If I said someone is satisfied when they're not, does that have any grave societal implications? Saying someone's a satisfied Nordy shopper when they're not? Will the world still turn pretty well on its axes? Probably. So, there it's okay, but unfortunately, as I say here, it's going to be really hard for you to get published. There might be some journals, if you have a really elegant design, interesting methods, and maybe you frame it as partially exploratory, they might. But I bet you those top tier journals, the APA, I think if that's your only finding, if that's your primary outcome, it's going to be a toughie. But I will say, I was a co-author on a paper that got accepted to a nice medical journal, and we had 0.062. And those cardiologists and physicians, they still live on that 0.05, even though I go over my speech on effect size and everything else. And they use terms marginally significant, or a trend. They use terms like a trend towards significance. And it got published, accepted to a nice journal of cardiac failure, and presented at the American Heart Association. So it's interesting seeing different fields have different emphasis on it. Also, if you have a very small sample size, your budget only allows 20 employees, you might loosen up on your alpha, right? What if it's a, maybe consider it your study to be a what, everybody? Does everybody know what a pilot study is? Or sometimes in nursing they call it a feasibility study, just to see if the IV will even work. Maybe call it a pilot. Even though usually a pilot assumes what? When you have a pilot, what does it usually assume? You're going to have a bigger study. What if you know your pilot is your study? Because they ain't giving you any more money for budget. So do you see all the constraints you have to be very realistic about in operating? What's nice about having a pilot study is if you have no idea about the effect size, you can get an idea of that for a power analysis. Now, one way of really messing up type 1 error rate, which the book starts talking about on page 5, right, is to do tons of significance testing. Right? You have 10 job satisfaction questions, and you know what? Go and do 10 t-tests. It doesn't take very long to do it, does it, everybody? 10 t-tests takes a few seconds of, right, computer time. So, that being said, as you know, type 1 error goes through the roof. This little formula that I like, there's a few different with this. Remember this one, everybody? 1 minus alpha raised to the power of k, the number of tests. You may remember that from ANOVA. If you just run 10 t-tests, and you're thinking it's 0.05, which was your overall alpha, your overall type 1 error rate, when we do 1 minus alpha raised to the power of 10, it goes up to 40%. Does that seem pretty high? To have a type 1 error rate of 40%. How many studies do you think will get off the ground if we say 40 times 100, you're saying there's a difference when there isn't? 40 times. How would you like it if out of 100 times you take your car to the auto mechanic, 40 times they say something is wrong when it isn't? Which maybe is the going rate in the industry. But that being said, you can see how things just absolutely compound with this type 1 error rate. So one way to control is to use, remember the good old Bonferroni, everybody, inequality? The Bonferroni inequality is really something very simple. Alpha, does anyone remember what PC means? Does anyone remember what PC means? PC equals per comparison. So alpha per comparison equals the family-wise error divided by the number of tests. Where family-wise equals family-wise error. So, let's say your family-wise error, which is what you set. You have 15 job satisfaction items, 10 job satisfaction items. Let's say you set it at 0.15, which means 15 times 100, you're going to say there's a difference when there isn't for this family of analysis. Who sets this, you or the computer? Who sets the family-wise error, you or the computer? You do. So let's do 0.15 divided by 10. So now you're only going to say you have significance when your p is less than what, everybody? 0.015, exactly. So now you will have an alpha for each of your 10 t-tests be 0.015 instead of 0.05. So which error have I decreased? Which error have I decreased? What's that, Chad?
You've decreased type 1 error.
You got it. So now I have decreased type 1 error, but maybe you have increased what?
Type 2.
Yeah, you got it, Chad. Right? Right? There's a balance there. Now it's going to be, is there a chance? In other words, for example, if one t-test had p-value of 0.04, you will now reject or fail reject. You have 0.05? Yes. And in the old days, for 0.05, you would have rejected. Do you see the difference, everybody? Now, guess what? That ain't no longer significant. So I do sometimes do that with my clients. I do with my clients. If I use something like this, I say, you know what? We're using maybe a 0.01, 0.02 for the comparison, and now we're no longer going to say we have significance. But now at least we're keeping type 1 error in check, delimiting the rate of what? False positives or false negatives? false positives. You got it. So again, we want P to be less than or equal to alpha. And our P is the probability of the outcome given the true null hypothesis. That's what a p-value says. Does a p tell me anything about strength? No, it doesn't. So let's discuss power now. So power, what influences power, everybody? And this is straight from your book. We know that sample size. The larger, the more power, right? If you have the luxury of more people, it'll be easier to find significance. Alpha, the higher, the more power. And I know that seems weird, but if I go from 0.05 to 0.10, is it easier or harder to find significance now? Easier. But what's the trade-off? What's the trade-off? Increased type 1. Effect size. The larger, the more power. If you have a better mousetrap, stronger effect, better predictor, it's going to be easier to find significance. And direction. One tail has more power than two tail, but you better be really right about what? Direction. Right? So we know that if you say that you think those who receive counseling will have better outcomes than those who receive medications, and you're looking at this tail, if it ended up way over here, do you get to take credit for it? And I'm discussing this with the TAs in my undergraduate class, because it's kind of weird for our project at the end of undergraduate stats. They can have a one-directional test for correlations and t-tests, but we're going to have them use a two-tailed critical value to make it a little more conservative. But I did say, how are the TAs going to handle it if the computer spits this out? T equals negative 3.2, P equals 0.002. In other words, what if it ends up over here and the computer's going to spit out a significant P? What would you guys do? What would you do if you had a good old t-test? Good old t-test. You had a directional hypothesis and, wow, P of 0.002, negative 3.2. It ended up over here. That those who got medication did better than counseling. What are you going to do as your final determination? Because remember, the computer's going to spit out 0.002. What's your conclusion? Okay. So,
Your board's going to turn on.
thank you. Okay, so this is now. What if your directional hypothesis, right, is HA group 1 larger than group 2, and T equals negative 3.23, and P equals 0.02, and you have the wrong direction. Remember very briefly I talked about type 3 error? Remember very briefly type 3 is, some people call it the right answer to the wrong question. It's when you say, guess what, I thought I was going to go this way, oops. So technically, if I just let the computer spit out, you reject the null because the P is less than, but you were wrong about direction. Which is why there's some authors that say you should always be more conservative and have just a what? Two-tailed test. Right? So there's some interesting thoughts about that. But technically, you're right, Zach. You would fail to reject null. Yeah, it's going to be weird. You're going to say P equals 0.02. You see, it's P less than 0.05.
Why would you only use a one-tailed test?
Why would you use a what?
One.
You know, think about if you had a drug and a placebo. It'd be weird to think at all that the placebo should have a stronger effect.
Weird but possible.
It is, well, you know, yes. Yes, it is possible. And you know what? If there's ever that element of possibility, just stick to the two-tail. Once you get to multivariate stats, don't worry about it. There's no one or two-tail option. Multivariate is multi-directional, so you don't even have to worry about it. It's the simpler ones, the correlations, the t-tests. So everybody, what does the effect size get at, everybody? What is an effect size? Magnitude, right? It gets at magnitude. And 6021, we talked about eta squared and omega squared, right? We used r squared, eta squared, and omega. And in regression, we used correlation, r squared, semi-partial, partial correlation, all types of effect sizes. So the effect size gets at strength. If you build a better mousetrap, is it easier or harder to find significance? If you build a better mousetrap, easier or harder? If you have a stronger effect. Yes, exactly. The larger the effect, the higher the power. Right? Easier to find differences. So that means why we do power analysis. Lots of books on power now. This was kind of the first one, Statistical Power Analysis by Cohen. That was one, but there's been quite a few since then about power analysis. Statistical power analysis, a nice one that's got some nice syntax examples, which I've included in this presentation. Applied power analysis for behavioral sciences, effect sizes for research, how many subjects, lots of stuff out there on power analysis. Now part of this, when you do a power analysis, and we're going to discuss power in this class, is you got to be really clear on your design. And you guys, I see people that still report the wrong effect sizes given the design. Is it a J group design? Are there 2 groups, 3 groups? Is it a single group design? Is it cross-sectional? Right? Is it repeated measures or time series? Is it a mixed ANOVA? You have a between and within, 2 groups across time. Or are there mixed effects? Are there random parameters? Is it a correlational design? Is there a hierarchical approach? Is it a crossover trial or switching replications? Do you guys know what crossover trial is? Drug A, drug B. Group 1 gets drug A, then drug B. Group 2 gets drug B, then drug A.
Seems a little bit dangerous, doesn't it?
You got to be really careful about crossover. You got to think about what's called a washout period. A washout period. I'm a consultant on a crossover trial now, looking at hormone replacement therapy, and these are clinicians, so they know they're going to do 6 months in between. So yeah, you have to be really mindful about what's called the washout period, so that there's a dampening of the effect. Switched replications would be intervention, then control for group 1, control, then intervention for group 2. I have someone in your consulting psychological program that's actually proposing a switching replication design right now. So they're unusual designs, and you have to be really mindful about the design. I still sometimes see people do this, everybody. Sometimes I still see, I may have said it right here. Okay, maybe I don't write it here. I still see sometimes people say that my effect size is 0.3. That tells me nothing. Is it a correlation? Is it an odds ratio? Is it a mean difference? How many groups are there? I've seen people use correlation effect sizes for regression techniques. So you've got to be really certain that the proposed analysis corresponds to your design and the effect size and the metric corresponds. So you see, all that needs to be taken into account for power analysis, everybody, when you do a power analysis. Again, and be mindful, as the book discusses on practical versus statistical significance. The book starts discussing on page 8. Right? Just because something is statistically significant doesn't mean practically it matters. Say you have 334 per group. And Zach finds T is 666 degrees of freedom, 3.45, P is 0.003. And this is what Zach finds. I'm looking at intelligence between males and females. Wow, look at that nice graphic Zach's going to present. Zach's got significance. It goes with his hypotheses. Look how much brighter males are than females. Any concerns? look at my y-axis, right? That's the default of Excel. And SPSS does that too. 100.7, 100.5, 0.2 difference. Is that a big difference? So that Zach can come up with his male supremacy theory. No. But, and maybe the effect size might also be small. So do you see, you got to also not be so deluded by, or so engrossed with p-values if you get something like this. Right? Because what if you have the luxury of a large database? Well, some of you, at least one of you in this room, given recent trends, will do what's called secondary data analysis. You'll go work for Center for Creative Leadership, and you'll have a database right there for you. You'll have a database set up there for you, and it'll have 1,500 managers. And it's going to maybe be easy to find significance, which means your attention should turn to effect sizes and confidence intervals. Right? Problem is, many associate significance with what? What did we say in both of my classes? Importance. Right? The average consumer, when they hear in the newspaper that there were significant differences between those who got counseling versus not, guess what they tend to associate it with? It's important. It's big. It's large. It matters. But statistically speaking, it may not. So part of your homework is reading Cohen's 1994 article, classic article now, on null hypothesis. It's weird to call it classic now, since it's almost 20 years old. It still seems new to me. But as you know, I've appended this on Moodle. And I just added Nickerson's nice little 60-page report from Psych. I think it's Psych Methods. Also does a great job of talking about significance testing. So your first homework is a fun one. It's going to be an opinion paper on those two, your personal opinion and reaction. You may have to reread, especially Cohen the second time over, because it gets into kind of what's called Bayesian modeling. But start thinking about significance testing. There are more recent papers I could assign. In fact, I just read another one on significance testing. But these will do some thinking. And as you know, I've talked about this book before, What If There Were No Significance Tests? And this book starts off with Cohen's paper. It has tons of chapters. Thankfully, they haven't gotten rid of significance testing, but there are many people that would love to. There are many people that would just love to abolish significance testing and put more of an impress on effect sizes and what else? What's the second statistic you've heard me talk until I blew in my face? That AP unfortunately does not require but encourages. Confidence intervals, right? And we'll discuss that in this class. So what do you do if you have a large effect size and no significance? You know, you have an R of 0.737, wow, P of 0.095, but you have 6 people. IQ and number of dates. Zach, being now 30, is interested in this relationship. So he gets 6 of his 30-year-old friends, measures their IQ and the number of dates. Wow, Zach's with really bright people. All his friends have really high IQs, but boy, their social life is not so good. They're all getting their PhDs and so forth, and just hitting that kind of that 30, plateau. And so that being said, you have a correlation of negative, you have a negative 0.74. Wow, what a nice effect size. So what are you going to say about the study? Maybe get more people? Or Zach could do this. So does Zach reject or fail to reject, everybody? So does Zach reject or fail to reject? Yes. You got it. Does he fail, everybody? But Zach, being somewhat crafty, takes 0.095 divided by 2, which equals 0.0475. Because look, everybody, do you see it's two-tailed? And now it's one-tailed p-value. Any problems with that? Does everybody see what I did? Look at that, everybody. 0.095, but it's two-tailed. So I'm going to split it in half, and now he gets to what? And he gets to, anybody have problems with that? Anybody have problems with what I just did?
Yes.
Because,
Changing the nature of our study every year.
but do you see all the stuff you could potentially do? Right, do you see all the stuff you could do? Probably not in academia, because usually you have to write this stuff in a proposal, but out in the real world.
Oh, they must do it.
Academia?
No, out in the real world.
Yeah, I mean, I don't know. I can't answer that because I don't know. But you can see how easy it would be to do it. I mean, all I have to do is say, oh, one-tailed p-value is 0.04 and we reject the null.
Like I just saw this commercial where this guy is now getting all of his money, his paycheck money, put on a visa, a prepaid visa, and it says, I can spend more time with my child. That's why you should do it.
Right.
And I says, what? 15 minutes every 2 weeks that it takes you to go to the bank?
Right.
No, so if you, like we have that mentality as a culture, that persuasive, to, like it's significant amount of time, but it's not really.
Absolutely. That's why some people say there's 3 types of lies. Lies, white lies, and statistics. Which of course, when I've heard that, I've gone, oh, have you heard this joke? And I go, yes. And it's not, most statisticians aren't going to lie. People think, well, you can get numbers to say anything you want. Well, I've heard that a million times. Yes, that's true. You can do that with any type of information.
Yeah.
99.9% I'm sure are absolutely honest. Yes, there are some people that may use the data for their own purposes. So here, is Zach using it potentially for his own purposes? Maybe. So APA, you've got to report effect sizes, and it'd be nice to report confidence intervals. Because confidence intervals not only show me significance, but they give me an idea of what?
Ranges.
Yes, sampling error, right? The because it includes the standard error. So confidence intervals are really nice to show that. Now what about this? And I've shown you this example in my regression class. I said, you know, you guys, I decide that I'm going to encourage Chad to drop out of school today because I really want Chad to be happy in his life. He's got a family, he's a busy guy, I feel he's overworked. Because I didn't tell Chad that, you know what? The more education you have, oops, the less happier you are. Negative 0.115, it's significant. Right? So am I telling the truth if I say there's a negative and significant relationship of happiness and education? The more educated you are, the more bugged you are. But look, I have 2,795 people. Is that a pretty nice sample size? And is that a pretty small correlation? I mean, look what, I can sometimes work with databases, everybody, that if I have much more than a couple thousand, correlations as low as 0.05 are significant. They're significant. But again, you have to think about that. Which is why books such as this, Understanding the New Stats, talks about effect sizes, confidence intervals, meta-analysis. Meta-analysis. You have 20 studies that only have 40 people each. But then you can maybe combine them all to get an idea of patterns for effect sizes. It's a wonderful book. I know you've seen me present this book, but I like the fact that it impresses effect sizes, has some great applets, and confidence intervals. Does one group seem to have more variability than the other? Absolutely. Absolutely. The confidence intervals not only can show me those point estimates, but they can also show me the variability. And did you find that with confidence intervals, I can also see if we have significance? If it includes what? Magic number. 0, right? Whether it includes 0 or not. So why don't we go ahead and take a 15-minute break. It's 10:19. Take 15, stretch it out, and I will resume talking at 10:34. And even if no one is here,